Hi guys, so today we are going to continue what we've done with quadratics and we're going to continue to look at parabolas, but now we're going to look at parabolas just a slightly different way. So we looked at some things in class. If you didn't see them, there's some links on Schoology that you can play with just to kind of see what this does. But one of the things we talked about is how a parabola is not just a quadratic equation. A parabola is actually the set of all points that are equidistant from a line and a point. That line was called the directrix, and that point was called the focus. So then there's a few things that we talked about on there. So P is a value that's in our equation. That is the distance from the focus to the vertex or from the directrix to the vertex. So for example here, that distance right there would be P. But I also could use this distance right here. It's going to be the same total distance. That's why we say absolute value. Same thing if it's horizontal. That distance right there would be the same as this distance right here. And that's going to be that P value that we use in our equation. No matter which direction your parabola goes, the focus is always inside the parabola. The directrix is always outside the parabola. So the focus is inside, the directrix is outside. All right, what we're also going to look at today is how to get some additional points on this parabola. We're going to use something called the latus rectum. So the latus rectum is a chord. It's parallel to the directrix, and it goes through the focus. So it's going to be a chord like this right here. So what that helps us find is two additional points that are on our graph. That way we don't have to worry about parent function transformations. We can just find those 2 points since we're already graphing the focus. The total distance of that line is 4p, which means that the distance basically of half of it, so from the focus, we'll move a distance of 2p on each side to get those other 2 endpoints. So from the focus, I would move a distance of 2p to get to 1 point. I would move a distance of 2p to get to the other point. All right, so again, this is just a review. We did this in class, but again, the line here would be the directrix. That point inside would be the focus. That's my vertex. And then these are the endpoints of the latus rectum. So that's just 2 additional points that are on that parabola. All right, so what we have in your notes, we have this chart here that we're going to fill in with a lot of information about our graph. So this equation looks very similar to vertex form that we've been using for transformations. The only difference really between this equation and the one we've been using for transformations is that this is in the form of 1 over 4p. So that p value, remember, is how we determine where the focus is in relation to the vertex or the directrix. So a couple things about that. If that p value is positive, so if that p value is greater than 0, then this parabola is going to open up. If that p-value is less than 0, so if it's negative, then that parabola is going to open down. So very similar to what we just did with transformations. Now you'll notice in here it gives you another form of this equation. That is the exact same equation, it's just written a different way. You do not have to use that equation if you don't want to. I just wanted you guys to see it because when you get into conics and pre-cal, you may see it written in that form instead, but it is the exact same equation. But we're mostly going to use that equation up there at the top instead. All right, so the axis of symmetry, again, for vertical, it's still x equals h. That is not changing. The focus, like we said, the focus is always going to be inside that parabola. So let's say that that is my focus. So if I were to actually plot that point, the x-coordinate is not changing. So the x-coordinate of the focus is going to be the same as the vertex. What is changing is the y-coordinate, and the y-coordinate is changing. The distance that it is greater is by the amount of p. So what I would do to actually find the y-coordinate of the focus is I would take the vertex and add the value of p. Now if that's difficult, you're okay. When we graph these, it'll actually be a little bit easier to see. All right, directrix, like we said, is always the line outside of it. Well, if it's a vertical parabola, then that line is always going to be a horizontal line. So it's always going to be a y equals line. Where that line's located, again, it's a distance of p away from my vertex. And then since it's going to be outside of our parabola, we can't add p because that's where the focus is. We're going to subtract p. Okay, because remember, if p is negative, that's going to flip everything. All right, so now let's look at our parabolas that are going to open horizontally. So parabolas that open to the right and parabolas that open to the left. So what you'll notice about the equation, the y is squared and the x is not. That's the biggest difference in the equation. That's why these are not functions. If p is positive, the positive horizontal ones will open right. The negative ones will open left. Axis of symmetry, this time, where it cuts in half, it's going to be a horizontal line. So it's going to be y equals k. All right, the focus is always inside the parabola. So let's say I have a parabola like this. There's my vertex and my focus. Well, this time the x-coordinate of the focus is what's changing from the vertex. So I would take the h of the vertex and I would add p. The y-coordinate is not changing. If I want to write the equation of the directrix, it's a vertical line, no matter which way it's going. So it's going to be x equals. And again, since it's outside the parabola, we are going to subtract the value of p. Now, these equations that we just wrote here, you do not have to memorize those equations. We can always determine this from the graph. As long as you remember the focus is inside, the directrix is outside, and the distance from either one to the vertex is basically the absolute value of p. Then as long as we know that, we don't have to memorize those equations. We can just graph it out to see what it's going to be. All right, so let's go ahead and do some examples. So what we're going to do is we are going to sketch the graph, we're going to write the equation, and we're just going to use it based off the information this gives us. So this gives us a focus. So the focus is -2, 0. The directrix is y equals 4, which is a horizontal line. So the first thing we need to determine is the vertex. So the vertex is going to be halfway in between those two things. So if the focus is at -2, 0, my vertex has to be at -2, 2. Since my directrix is above, I know that this graph is going to have to open down. If I want to get those other 2 points, to get it exact, I need to know what p is. Well, p is -2 because it's opening down and because the distance there is a distance of 2. So to get my other 2 points, the total distance of the lattice rectum would be the absolute value of 4p, so the total distance would be 8. But that means from the vertex, I would move over 4 and 4 to get those other 2 points. So now I have 2 more points on my parabola and I'm able to draw my graph. All right, so now let's work backwards. Let's write the equation. So to write the equation here, it's going to be y equals instead of x equals because it opens vertically. The vertex is at -2, 2. So again, it's opposite sign with the x. Then the number that goes there, remember, is 1 over 4p. So this is going to be -1 over 8. All right, now let's try this next one. Focus is at 2, 0. Directrix is x equals -2, which is a vertical line. That means that this graph is going to open to the right. Okay, this graph is going to open right. Vertex is that halfway point, which in this case is at the origin, 0, 0. P-value, it opens right, so it's positive. The distance between the focus and the vertex is 2. So then from here, I can get my 2 lattice rectum endpoints. So I would move 4 from the focus in one direction, 4 from the focus in the other direction, because again, it's a total of 8. So from the focus, I'm moving 4 each way. And that's my parabola. If I want to write the equation, this would be x equals y squared. There is no plus or minus on that because it's not changing. All right, let's try this last one. Vertex is at -3, 1. And then the directrix is x equals -7. So we have a little bit of different information this time. So I don't know the focus this time. What I do know is the distance from the directrix to the vertex is a distance of 4. So that means I'm going to move 4 away to get to the focus. We know we open away from the directrix, so this will open right. So we know this is going to be an x equals equation. Now remember when we wrote standard form for this, it's going to look a little different, and this is probably one of the biggest mistakes that gets made on these. In that equation, it's y minus k plus h. That should be a squared, sorry. So it's backwards from what you guys are used to, okay? The number that's with the y is the y coordinate of the vertex. So when I write this equation, it would be 1 over 4p, so that's going to be 1 over 16. It's going to be y minus 1 squared minus 3, because h is the x coordinate of the vertex, which is negative 3. K is the y coordinate of the vertex. So just be careful there. It's a really common mistake. All right, since my p-value is 4, I'm going to move 8 in both directions from my focus to get these other 2 endpoints. And then I have my parabola. All right, so let's go ahead and look at what we do if we're given the equation. All right, so now we have the equation. We're just going to determine some of the same things, but we're just working the opposite way. So again, this is x equals y squared. And actually, I'm going to change this. I'm going to make this x equals negative 1 over 8 squared, because we haven't done one that's going that direction. All right, so now that it says x equals negative 1 over 8 squared, this is going to open to the left. And if you notice this time it says concavity, it means the same thing, okay? This is going to be concave in that direction. So I think we talked about concavity at the very beginning of the year. So concave up, we said, remember, concave up looks like a cup. Concave down looks like a frown. Well, we're also looking now at left and right, okay? But the direction it opens is going to be the concavity for a parabola. All right, so our vertex here, okay, would be a negative 1 for the x-coordinate. Again, be careful. What's with the y goes with the y. The y-coordinate for this is going to be negative 2. Axis of symmetry, since this is going to open horizontal, is going to be a y equals equation. So this is going to be y equals negative 2. So to graph this, let's go ahead and plot our vertex. So negative 1, negative 2. All right, then from this point, I need to know the p-value in order to graph my focus and my directrix. So if negative 1 over 8 equals 1 over 4p, then negative 4p equals 8, so p equals negative 2. Again, we know it means it opens left, so from the vertex, I'm going to go 2 to the left for the focus, 2 to the right for the directrix. So after I've graphed it, it's a little bit easier to see the focus. So the coordinates of the focus would be negative 3, negative 2, and the directrix would be x equals 1. So then latus rectum, the length of the latus rectum is going to be 8. So that means from the focus, I'm going to move 4 away in each direction, and that helps me find the graph of my parabola. All right, so on this next one, it looks like it's in vertex form, and you could use what you've learned about vertex form in order to plot your vertex and your transformation and your vertical compression. But I want to go through this one the same way we've been doing it, just so it's a little bit easier for us to find the focus and the directrix. All right, so on this one, we know that it's going to open up because we know that it's y equals x squared, and our p-value is positive. So the vertex then is going to be 0, 1, because there is no h, and then my k-value is 1, which means my axis of symmetry would be x equals 0. So in order to find the focus and directrix, we need the p-value. So 3 over 4 is going to be 1 over 4p. That means that 4 is going to equal 12p. So p will be 1/3. So since this is going to be a little bit difficult to graph the way that it currently is, I'm going to change the scale on these, and I'm going to make each of these lines 1/3. And that'll just make it a little bit easier to graph and to see where my focus and directrix are. All right, so now my scale, each of these lines is 1. So my vertex is going to be at 0, 1. The focus, since it opens up, is going to be 1/3 away, so that's going to be one of those lines. So there's my focus. Directrix would be below that, and it'll be a horizontal line because it's opening up. So my focus would be at 0, 1 and 1/3, or 4/3. Directrix would be at y equals 2/3. And then the two endpoints of that parabola, so the total distance, that 4 p-value, would be 4/3, which means I'm moving 2/3 on each side of my focus. So that's 2 lines on each side away from that focus point. And there's our parabola. All right, so that's it for focus and